Okay, welcome back to another video. Today I have a past paper on integration by parts, a rather tricky question. And just to recap, integration by parts is essentially when you have a function, when you're integrating a function that's being multiplied by another function, for example, f of x times d of x. It is the inverse of the product rule when differentiating, but there are a lot of steps, and I'll go over a practice question before we get to this past paper. So say I've got the integral of x times e to the power of x dx. To approach this, we would first use look at our formula booklet and use the following formula as highlighted. Please take note of this. I'll write it down. It is the integral of u dv, which is equal to uv minus the integral of v du. Just check if that's correct. Yeah. So essentially, u and v are substitutions that we're going to have to make. And to substitute u with something, we follow this order called Liat, L-I-A-T-E. And it essentially tells us the priority of different types of functions. So this would be logarithmic functions. This would be inverse trig functions. So your arcsine, arctangent. This would be algebraic functions. This would be your normal trig functions, so sine, cosine. And this would be exponential. So if we look at our practice problem up here, x is algebraic and e to the power of x is indeed exponential. And you can see that algebraic is prioritized higher than exponential. Therefore, for this we will set u equal to x. And because of that, dv is always going to be e to the power of x dx. And we want to get du and v. So to get du, we differentiate u with respect to x. So du over dx is equal to 1, therefore du is equal to dx. And v is going to be the integral of dv, which is the integral of e to the power of x dx, which is very simply just e to the power of x. So combining everything together, we've got the integral of u dv, which is just x times e to the power of x dx, is equal to uv, which is going to be x times e to the power of x, minus the integral of v, which is e to the power of x, and du, which we said is dx. And this is just equal to x times e to the power of x, minus e to the power of x and plus our integration constant c. So you can just factorize this and write e to the power of x times x minus 1 plus c. And that is going to be the answer. So anyways, that is just a very simple problem to integration by parts. It's meant as an introduction for those who aren't aware about it or have little knowledge about integration by parts. And for those that do, we will start with this practice problem. So part A is worth 6 marks. So write the integral x times natural log of x to the power of 2 dx. So using our LIATE priority list, we can see u would be the natural log of x squared, as it is a logarithmic function. Therefore, dv is equal to x dx. And I'll just write the form again from the formula booklet. It's the integral of u dv is equal to uv minus the integral of v du. So differentiating u now, we get du over dx is equal to 2 times the natural log of x squared multiplied by 1 over x, because it's a chain rule, which we can divide by x. So du is equal to 2 times the natural log of x squared divided by x multiplied by dx. V is equal to the integral of dv, which is the integral of x dx, which is x squared over 2. So writing everything in our form, we get the integral of x times natural log of x squared dx is equal to uv, which is u would be the natural log of x squared multiplied by x squared over 2 minus the integral of v du, which would be x squared over 2 multiplied by 2 times the natural log of x squared over x dx. Okay, so essentially now we need to evaluate this integral, and before we do that we can simplify that. So I'll just write it here. The 2's would cancel out here, and the x's would also cancel out. So you are left with the integral of x multiplied by the natural log of x squared dx. Actually, so I am so sorry. This would just be the natural log of x, because the 2 would be reduced to 1 from our power rule. So with that, we just get the integral of x times natural log of x. I'll just make the corrections. I apologize for that mistake. Now again, we have this integral and we can't evaluate it using our normal rules because it's one function x multiplied by another, natural log of x. So again, we are going to need to use integration by parts. So we can make u the natural log of x and dv x dx. That means du over dx would be 1 over x, and du is equal to 1 over x multiplied by dx. V is going to be the integral of dv, which is the integral of x dx, which is x squared over 2. So we can write this x natural log of x dx, the integral of that, which is equal to uv. So that would be x squared multiplied by natural log of x over 2 minus the integral of v, which is x squared over 2 du. So 1 over x dx. And before moving forward, the reason we're using integration by parts again is because when we use the original formula, we got a natural log of x squared over 2 minus the integral of x times natural log of x dx. So this is what we call a chain integration by parts, where we will need to use integration by parts again to get to our final answer. And it is very common in AAHL papers because, as I said, the IB loves to twist up concepts that you learn. So expect questions like this in papers. Anyways, coming back to the integral, we can cancel out the x's, which leaves us x squared natural log of x over 2 minus the integral of x over 2 dx. And this is just x squared ln x over 2 minus x squared over 4, because x becomes x squared and then you divide that by 2, which is already divided by 2, so that becomes 4 as your denominator. And finally, we can put this into our original problem, which was the integral of x times the natural log of x squared dx, which is going to be the natural log of x squared times x squared over 2 minus what we have got up here, which would be x squared ln x over 2 minus x squared over 4 plus c, our integration constant. So just simplifying everything, we get ln x whole squared times x squared over 2 minus x squared over 2 ln x plus x squared over 4 plus c. We can factor out x squared, so we get actually it's better if we don't need to factor it out. Just get x squared over 2 times ln x squared minus x squared over 2 ln x plus squared over 4 plus c, and that is part A's answer. Yeah. Now part B is asking us to integrate, to make this a definite integral where we integrate over the bounds of 1 to 4. And that is worth 3 marks. So we have the integral from 1 to 4 of x times the natural log of x squared dx, which is going to be what we've evaluated in part A. Okay. Oh, I'm running out of space, okay. 2 ln x plus squared over 4 from the bounds of 1 to 4. So this would be equal to 4 squared over 2 times the natural log of 4 squared minus 4 squared over 2 times the natural log of 4 plus 4 squared divided by 4 minus 1 squared. Okay, the 1 squared is 1, so 1 over 2 multiplied by the natural log of 1 squared minus 1 over 2 natural log of 1 plus 1 over 4. Okay, so now before we proceed, I want to just remind you of some basic log rules. The natural log of 1 is actually equal to 0, and that's because the natural log has a base e. So using our log rules, e to the power of 0 would have to be 1. Therefore, natural log of 1 is 0. So we can simplify everything and cancel out these terms, because natural log of 1 is 0 and you're multiplying half by 0, which is nothing, it's 0. So anyways, simplifying, we get 4 squared over 2, which is 8, multiplied by the natural log of 4 squared minus 8 natural log of 4 plus 4 minus 0 plus 0 minus 1 over 4. So this can be crossed out. So just erasing that, we get minus 1/4. This is equal to 8 times natural log of 4 squared minus 8 natural log of 4 plus 16 over 4 minus 1 over 4, which is 15 over 4. And we can simplify this further because natural log of 4 is equal to natural log of 2 squared, which is 2 natural log of 2. So substituting this, we get 8 times 2 ln 2 squared minus 8 times 2 ln 2 plus 15 over 4. And that would be 8 times 2 squared, which is 32. So I'll write that as 32 times natural log of 2 squared minus 8 times 2, 16 natural log of 2 plus 15 over 4. And this is our final answer. Let's confirm if it's correct. 13 ln 2 squared minus 16 ln 2 plus 15 over 4. And yes, that is the correct answer. So this was a pretty difficult problem. There were a lot of steps involved for sure. And the key is you just want to follow the process of the integration by parts formula, given the formula booklet. If you can follow that, and if your algebra skills are good, you should be able to solve a question like this. But of course, it does come with practice, and this is the hardest IB course. So yeah, just continue to practice, and you will eventually get the skills you need to solve this. Thank you. If you enjoyed this, please like, subscribe, and comment.